Let's look at integration parts. Basically, if we have to figure out the integral of function, we can use this formula kind of thing. Integral of u dv is equal to ub minus integral of v du. Okay, it will make sense when we actually start solving problems. So let's look at the first one. Integral of sine inverse of x dx. Now here, if you notice, we have a function sine inverse of x, but we don't have the other function. So what we'll do is we will take it as sine inverse of x times 1 dx. So this becomes the second function. So here u would be sine inverse of x, and remember we want dv. So this is going to be dv 1 dx. So dv is equal to 1 dx. What we'll do is we'll integrate both the sides. So we get v is equal to x. Okay. Now du would be, remember here we require du, we require dv, and we require u and v. So the derivative of this is 1 by square root of 1 minus x square dx. Okay, now that we have all these parts in place, let's combine them into that formula. So integral of sine inverse of x times 1 dx is equal to uv. So x sine inverse of x minus integral of v du. Integral of v is x, du is 1 by square root of 1 minus x square dx. So now we have to take care of that integral. That is x by 1 minus x square. So let's do this. Let's say s is equal to 1 minus x square. So ds would be minus 2x dx. Here what we have is x dx. So let's take this minus 2 to this side. So we get integral of x dx is ds divided by minus 2 square root of s. Okay. X sine inverse of x minus times minus plus 1 by 2 integral of ds, or what we can do is bring that up. So square root of s can be written as s to the power of, because we have brought it up, minus 1 by 2 ds. Okay, now x sine inverse of x plus half, and if we integrate it, what do we get? S minus half plus 1 by minus half plus 1, which gives us x sine inverse of x plus 1 by 2 s to the power of 1 minus half is half by, and here again we have half, so 2 and 2 cancels, and we have x sine inverse of x plus square root of s. Okay, now let's reverse substitute x sine inverse of x plus square root of, what is s? S is 1 minus x square, and plus c, the constant of integration. Look at the second one. Integral of cos inverse of x dx. Again, what we'll do is we will say times 1, so that we have two functions. So here u is equal to cos inverse of x dv is equal to 1 dx. If we integrate both the sides, we get v is equal to x. Du would be minus 1 by square root of 1 minus x square dx. Okay, we have all the parts in place. So let's solve this. uv. So x cos inverse of x minus integral of v du. V is x times minus 1 by square root of 1 minus x square dx. Now, x cos inverse of x minus times minus plus integral of x by square root of 1 minus x square dx. Now we have to solve this integral. We already done it, but let's do it again. So let's say s is equal to 1 minus x square. So ds is equal to minus 2x dx. So minus 2 we bring it to this side, right? So our integral becomes, let's write it fully, plus integral of x dx is ds by minus 2 and square root of s. So now we have x cos inverse of x minus 1 by 2 integral of s to the power of half, no, minus half because we brought it up, ds, which would give us x cos inverse of x minus half, and this will give us s minus half plus 1, that is half, divided by 1 by 2. So 2 cancels, and we have x cos inverse of x minus square root of s is 1 minus x square plus c, integral of cosec inverse of x dx, right? So now again times 1 dx. So u is equal to cosec inverse of x du would be minus 1 by x times square root of x square minus 1 dx, and dv is equal to 1 dx. So if we integrate it, we get v is equal to x. So let's do the evaluation. uv, so x cosec inverse of x minus integral of v du. So integral of v is x and du is minus 1 by x square root of x square minus 1 dx. X and x cancels, minus if we bring it out it becomes plus. So we have x cosec inverse of x plus integral of 1 by square root of x square minus 1 dx. And if we integrate this, what do we get? Now we have to integrate this. So this is going to be tricky. So here we have square root of x square minus 1. So let's say uh, x is equal to sec theta, right? Now why we are using sec theta is sec square theta minus 1 we know is going to be tan theta, right? That's the basic idea. So let's see what happens. So this will become integral of 1 by square root of sec square theta minus 1, and dx would be what? So here dx would be sec theta, derivative is sec theta tan theta d theta, right? So, and we will write times sec theta tan theta d theta. Okay, now this becomes sec theta tan theta d theta divided by tan theta. Tan theta and tan theta gets cancelled, and we are left with integral of sec theta d theta. And when we integrate sec theta, what do we get? We know, we have done this previously, is going to be natural log of sec theta. Let's take it as sec theta plus tan theta. Okay. And the sec theta is nothing but x, and tan theta is nothing but x square minus 1. So we have got this. So let's write this into our main flow. Cosec inverse of x plus natural log of x plus square root of x square minus 1 plus c. Okay. Now, if we remember, we either we can do it like this, integration of this, or we, if we remember, we also know that cosec inverse of x plus an integral of 1 by square root of x square minus 1 dx is also hyperbolic cos inverse of x plus c. So depending on the context, we can choose whichever of these is relevant. Fourth one, integral of cot inverse of x dx. Again, we are going to take times 1 dx. So u will be cot inverse of x, and dv is equal to 1 dx. So if we integrate both the sides, we get v is equal to x. And here du would be, now the derivative of cot inverse is minus 1 by 1 plus x square dx. So let's incorporate all these parts. uv, that is x cot inverse of x, minus integral of v du, that is x times minus 1 by 1 plus x square dx. So this becomes x cot inverse of x minus times minus plus x by 1 plus x square dx. Okay. So now let's see how we can address this integration. So if we have to do x by 1 plus x square dx, let's say s is equal to 1 plus x square. So ds is equal to 2x dx. That means ds by 2 is equal to x dx. Because x dx we have. So let's do the substitution. Cot, okay, let's do continue here itself, and finally we'll plug it in. Have x dx is ds by 2 times, and 1 plus x square is s. So this would be, no, not 2, 1 by 2 integral of ds by s, which is equal to 1 by 2 natural log of s, which is nothing but 1 by 2 natural log of 1 plus x square. Okay, so this will be cot inverse of x plus 1 by 2 natural log of 1 plus x square. This will always be positive because of x square, and it's an addition. So this will always be positive. Okay, and plus c. So this gives us the integral. Okay, fifth one. Integral of tan inverse of x dx. So here u will be tan inverse of x dx, no, not dx, tan x, tan inverse of x, and dv will be equal to dx, 1 dx. So v will be equal to x. du is equal to 1 by 1 plus x square, we know, dx. Okay, now let's plug it in. X uv. So x tan inverse of x minus integral of we have v du. So x by 1 plus x square dx, and x by 1 plus x square, we just now looked at that, right? Integral of x by 1 plus x square, and we know that is 1 by 2 natural log of, so tan inverse of x minus 1 by 2 natural log of 1 plus x square plus c. So the difference between cot inverse and tan inverse is, apart from the obvious one, that is here we have tan inverse, here we have a minus sign. In cot inverse we have a plus sign. Okay, now sixth one, integral of sec inverse of x dx. So again we make it times 1. So u would be sec inverse of x, du would be, now this is 1 by x times x square minus 1 dx, and our dv would be 1 dx. So if we integrate, we get v is equal to x. So let's substitute all these values into our formula. uv, that is x sec inverse of x minus integral of v du, that is x times 1 by x times x square minus 1 dx. So x gets cancelled, and we have x sec inverse of x minus integral of 1 by square root of x square minus 1 dx. And what will this be? Again, we can do the substitutions and figure out the integral of this. We will get sec x sec inverse of x minus natural log of absolute value of x plus square root of x square minus 1. Now, in many places, I might not have put this absolute signs. To be on the safer side, you always put absolute signs whenever you are using the logarithm. Okay, and plus c. This one we had arrived at for cosec, right? So here we have cosec. By the way, this should be absolute value, okay, to be on the safer side. Okay, so here we had derived that integral of 1 by square root of x square minus 1 by doing x equal to sec theta substitution. So here also, if you notice, here also we have integral of 1 by square root of x square minus 1. Okay, so now let's look at the next one, seventh one. Okay, integral of x 3 to the power of x dx. Okay, till now first six problems are more or less derivations, right? They were not actually problem solving. Okay, so let's do this. If you follow this I late, inverse trigonometric, logarithmic, algebraic, trigonometric, and exponential, right? Whichever comes first, that you take it as u. So here, this is exponential, which comes last. So first we give, and x is algebraic. So let's say u is equal to x. So dv will be 3 to the power of x dx. Okay, let's integrate both the sides. We get v is equal to 3 to the power of x by natural log of 3. Here we don't have to put an absolute sign because it is a positive value. Okay, and du would be dx. Okay, so now that we have all the parts in place, uv, so x times 3 to the power of x by natural log of 3 minus integral of v du. So 3 to the power of x by natural log of 3 times dx. Okay, so now x 3 to the power of x by natural log of 3 minus this is a constant, so natural log of 3 we take it out. Integral of 3x is 3x to the power of x by natural log of 3. Yes. So now here 3 to the power of x natural log of 3. Let's simplify this further. 3 to the power of x by natural log of 3 minus 3 to the power of x by natural log of 3 square plus c. So that is the solution. Okay, 8th one, integral of x sine 3x dx. Again, I let first comes algebraic. So u is equal to x, dv is equal to sine 3x dx. Integrating this, we get v is equal to minus cos 3x by 3. Quickly, you differentiate this and see whether you get back sine 3x. Okay, du would be dx. So let's do the substitutions. uv. So x times minus cos 3x by 3 minus integral of v du. So minus cos 3x by 3 times x. No, the du. So this will be dx. Okay, so minus x cos 3x by 3 minus times minus is plus 1 by 3 we can take it out. So we have cos 3x dx. Now we have to integrate. So x cos 3x by 3 plus 1 by 3 times. Now cos 3x when we integrate, what do we get? We get sine 3x by 3. Quickly differentiate sine 3x. We get 3 cos 3x by 3, 3 disappears. Okay, so now this becomes, let's bring the positive quantity first. So we get sine 3x by 9 minus x cos 3x by 3 plus 9th one. Integral of natural log of 4x dx by x square. Here we have natural logarithm. So u would be natural log of 4x. So du would be 1 by 4x times 4x. So 1 by x dx. And dv will be 1 by x square dx. So if we integrate it, what do we get? We get minus 2 plus 1. So we get minus 2 plus 1 gives us minus 1. So when it comes down, it becomes plus 1. And then we also get the negative sign, right? So minus 1 by x will be the integral. Okay, now we have all the parts. So this would be equal to uv. So minus 1 by x natural log of 4x minus integral of v du. So minus 1 by x times du is dx by x. Okay, so this becomes minus 1 by x natural log of 4x plus integral of 1 by x square dx, which gives us minus 1 by x natural log of 4x plus, if we integrate it, we get 1 by x square. So x square minus 2 plus 1 by minus 2 plus 1, which is x to the power of minus 1 by minus 1, which gives us minus 1 by x. So this will be minus, so instead of plus, minus 1 by x. Okay, and now since 1 by x is common, let's take minus natural log of 4x minus 1 by x plus, okay, next one, 10th one, integral of x e to the power of minus x dx. Again, exponential is the last one, so let's say u is equal to x, dv is equal to e to the power of minus x dx. If we integrate this, we get what? We get v is equal to e to the power of minus x by natural log e. These two cancel out. We have e to the power of minus x. If you differentiate it, what do you get? E to the power. So there has to be a minus sign as well. Here du will be equal to dx. So all the parts in place. So let's integrate uv. So that is x times minus e to the power of minus x minus integral of v du. So minus e to the power of minus x du is dx. So this becomes minus x e to the power of minus x. Let's take minus out. So this becomes plus integral of e to the power of minus x dx. So minus x e to the power of minus x plus, if you integrate it, what do you get? E to the power of minus x. That's all. So if you differentiate it, you get minus e to the power of minus x. So we need a minus as well, so that it becomes plus. So this would be minus x e to the power of minus x minus e to the power of minus x, and we have e to the power of minus x common. So let's take it out and let's say x plus 1. And since e to the power of minus x is negative, exponent is negative, let's take it up, down, e to the power of x. So that is the integral plus c. We should not forget that. Now let's look at the 11th one. Okay, so integral of cos inverse of 5x dx. Now let's do one thing. Let's convert this into a single unit. So let's say t is equal to 5x. Things become simpler. So dt would be equal to 5 dx, which means dx is equal to dt by 5. Okay, so if we do the substitution, we get cos inverse of t dt, and 1 by 5 we can take it out. So this is what we end up with. And now let's do integration by parts. So we have times 1. So what we'll do is we will take u is equal to cos inverse of t and dv is equal to dt. If we integrate this, we get v is equal to t. And here we get du is equal to cos inverse is 1 by square root of 1 minus t square dt, right? Now let's do the substitutions. We get 1 by 5 uv. So t cos inverse of t minus integral of v d. So that is t times minus 1 by square root of 1 minus t square dt. Okay, now let's split them up. We get 1 by 5. T is 5x cos inverse of 5x. Let's finish off this here itself, and then let's take the second term. So here again we have 1 by 5 minus, if we bring it out, it becomes plus t by square root of 1 minus t square dt. Okay, 5 and 5 cancels, and we have x cos inverse of 5x plus 1 by 5. Now its integral we have to figure out. So let's take s is equal to 1 minus t square. So ds is equal to minus 2t dt. That means ds we can bring minus also, by 2 is equal to t dt, because we have t dt here. So this becomes minus ds by 2 and square root of s. Okay, so x cos inverse of 5x plus 1 by 5. This minus again we can take it out. So this becomes minus. Okay, and we end up with 1 by 2 out, integral of ds and s to the power of minus 1 by 2. So we have x cos inverse of 5x minus 1 by 10. If we do the integral, we get s to the power of minus half plus 1 is half by half. So 2 5s. Now reverse substitution, cos inverse of 5x minus 1 by 5, s is 1 minus t square, that is 5x square plus c. This is the integral of cos inverse of 5x. Okay, so now let's look at the 12th one. Integral of natural log of x square plus 9 dx. So here let's take u is equal to natural log of x square plus 9, and dv will be equal to 1 dx. So this becomes v equal to x, and this becomes du equal to 1 by x square plus 9 times 2x. Okay, now let's assemble the parts. uv, so uv is x natural log of x square plus 9 minus integral of v du. So that is x times 2x by x square plus 9 dx. Here also we should write dx. So this becomes x natural log of x square plus 9 minus 2x square dx by x square plus 9. Okay, now what do we do? Here let's divide this x square uh, by x square plus 9. But before that, let's take 2 out. So if we divide x square by x square plus 9, what do we get? Once x square plus 9. So minus minus, these two cancels, minus 9. So what we end up with is 1 minus 9 by x square plus 9. Okay, so let's write it like that. Natural log of x square plus 9 minus 2 integral of 1 minus 9 by x square plus 9, and this will be within brackets, and we will have dx. Now the advantage of doing this is that now we can integrate it term by term. So we get 2 times integral of dx plus 2 times, or not 2, 9 2's 18. So plus 18 integral of 1 by x square plus 9 dx. So natural log of x square plus 9 minus 2x plus 18 is equal to x natural log of x square plus 9 minus 2x plus 18, And here what we are going to do is take out 9. So if we take out 9, what do we get? 1 by x square by 9 plus 9 by 9 dx. Okay, so this and this cancels, we are left with 2. So we have x natural log of x square plus 9 minus 2x plus 2 integral of 1 by x by 3 square plus 1 dx. And we know that we know the pattern, right? So this would be x square plus 9 minus 2x plus 2, and this would be tan inverse, right? So this would be 3 times tan inverse of x by 3. Final result will be x natural log of x square plus 9 minus 2x plus 6 tan inverse of x by 3 plus c. The next one, 13th one, integral of x cube times e to the power of x square dx. Here which one will be u? Because although we have exponential, but we also have this x square. Now think about it like this. This x cube can be split into x square times x. If we differentiate e to the power of x square, when we differentiate x square, we get 2x, right? So x will be there. So let's take u is equal to x square. So du would be 2x dx. Okay, first let's convert this into a form which is much more suitable. So what happens? We get this 2, we can bring it down. So x dx, so one of the x's, and we have x square. So we will have one of the x square will become u times, and we have 1x from here and e to the power of x square. But that, instead of looking at e to the power of x square, we have 1x and dx. So we write du by 2 times, now e to the power of x square. So that becomes e to the power of u. So we have u e to the power of u du, and this 1 by 2 we can take it out. So we have a product integral of a product of two functions. So now we can apply the parts, integration by parts. So here we have exponential and we have a algebraic. So let s equal to u and dv is equal to, let's not use v, let's take s is equal to u, and dt is equal to e to the power of u. So ds will be du, and if we integrate it, we get t is equal to e to the power of u by natural log of e. These two cancel out, we have 1, so e to the power of u we have. So now we have the parts, let's assemble the parts. We get 1 by 2 times uv. So uv is u e to the power of u minus integral of uh, uh, we will have t ds. So t is e to the power of u and ds is or rather du is du. Yes. So now 1 by 2 u e to the power of u minus, now its integral will be what? E to the power of u by natural log of e, which cancels out. So we have this. Now let's see, e to the power of u is common, so e to the power of u times u minus 1 by 2. Now what is u? U is x square. So e to the power of x square by or rather times x square minus 1 by 2 plus c. That would be the integral. 14th one. Integral of x e to the power of x dx by 3 times x plus 1 square. Let's take u is equal to x e to the power of x. So that when we differentiate it, we get, what do we get? Um, it's going to be a product rule we have to apply. So e to the power of x plus x e to the power of x by natural log of e. So that cancels. So which means we end up with e to the power of x 1 plus x dx. We should not forget that. And dv will be 1 by 3x plus 1 square dx. And if we integrate it, what do we get? We get 1 by 3 integral of 1 by x plus 1 square dx, which would be 1 by 3. We can write it as x plus 1 minus 2 dx, which becomes 1 by 3. If we integrate it, we get x plus 1 to the power of minus 2 plus 1. So minus 2 plus 1 is minus 1. And in the denominator also, we will end up with minus 1, right? So which means we will have minus 1 by 3 times x plus 1. Now that we have the parts, let's assemble the parts. uv, so x e to the power of x divided by, here we have v, which is minus 1 by 3x plus 1 minus integral of v du. So minus 1 by 3x plus 1 times e to the power of x 1 plus x dx. 1 plus n x plus 1 is same. So we have minus x e x by 3x plus 1 plus 1 by 3, we can take it out. We have e to the power of x dx. And that is pretty straightforward. So minus x e x by 3 times x plus 1 plus 1 by 3 e to the power of x. So now what else can we do here? What else? Let's combine them. What do we get? Minus x e to the power of x uh, plus, here x plus 1 is missing. So x plus 1 e to the power of x by 3 times x plus 1. Now simplify. What do we have? X e to the power of x. Let's bring the positive side first. X e x plus e to the power of x minus x e to the power of x by 3 times x plus 1. So here this and this cancels out, and we are left with e to the power of x by 3 times x plus 1 plus c. So that is the integral. 16th one. Integral of natural log of 3x square. Now here let's take u is equal to natural log of 3x square. Okay, so du would be 2 natural log of 3x by 3x times 3 dx. So we get 2 natural log of 3x by x dx. And our dv will be dx. So if we integrate it, we get v is equal to x. We have all the parts in place, so let's integrate them. So what do we get? uv. So x natural log square of 3x minus integral of v du. So that is 2 times 2 natural log of 3x by x dx. X and x cancels, and we can take out that 2 out. Natural log square of 3x minus 2 integral of natural log of 3x dx. Now here if you notice, in the problem we have natural log of 3x square. Here it has become 1, the power has become 1. Okay, so which means again we'll have to apply the integration by parts. Natural log square of 3x minus 2. Now let's do that. Here we will have s is equal to natural log of 3x, and ds would be 1 by 3x times 3, so that is 1 by x dx, and dt will be equal to dx, that means t will be equal to x. Okay, so we have s, ds, dt and t. So let's apply. st is going to be x natural log of 3x minus integral of t ds, so that is x times 1 by x dx. And now let's simplify. X natural log square of 3x minus 2x natural log of 3x minus x cancels, integral of dx is x, right? But 2 is also there, so minus 2x, but minus and minus will make this plus, so plus 2x plus c. Now let's look at the 16th one. Integral of e to the power of x sine x dx. Exponentiation is the last option in Eilert rule. So u is equal to sine x, du is equal to cos x dx. So dv will be e to the power of x dx. So v will be e to the power of x. Let's assemble the parts. uv, so e to the power of x sine x, not in the exponent, sine x, uh, minus integral of v du, so e to the power of x du, right? Now this is going to be tricky a little bit. Okay, so instead of e to the power of x sine x, we have ended up with e to the power of x cos x. Okay, let's take it further. um, e to the power of x sine x minus, now let's take s is equal to cos x, and dt is equal to e to the power of x dx. So ds will be minus sine x dx, and t will be equal to e to the power of x. So again now we do integration by parts. uv, now here uv we don't have, we have s and t. So s is u, t is v for our reference purpose. So uv will be e to the power of x cos x, uh, then minus integral of t ds. So e to the power of x times minus sine x dx. Let's write the full equation. Integral of e to the power of x sine x dx would be equal to e to the power of x sine x. Now let's open up this bracket. We get minus times plus minus e to the power of x cos x. We have minus times minus times minus, so that is minus integral of e to the power of x sine x dx. So here we have e to the power of sine x, here we have e to the power. So if we bring it to this side, this becomes 2 times, and then this 2 can be brought back here and divided by 2. So integral of e to the power of x sine x dx would be e to the power of x is common, sine x minus cos x by plus c. So that is the integral. Let's look at the 17th one. Integral of cos of natural log of 3x dx. Okay, so here times 1 we can take it. So let's take u is equal to cos of natural log of 3x. So du would be this will be minus sine natural log of 3x, and now we have to differentiate natural log of 3x, so which means 3x times, now we have to differentiate 3x, so 3. So 3 and 3 cancels, and we end up with minus sine natural log of 3x by x dx, and dv will be dx, so which means v will be equal to x. Now we have the parts in place, so let's evaluate uv. So x cos of natural log of 3x minus integral of v du, so that is x times minus sine natural log of 3x by x. X and x gets cancelled, we have a dx, and if you notice, instead of cos we have ended up with sine, so that means we need to do it once more. So x cos natural log of 3x plus integral of sine of natural log of 3x dx times 1. Again we do integration by parts. So let's say s is equal to sine of natural log of 3x. So ds would be sine will be cos natural log of 3x. Now we differentiate natural log, so 3x. Now we differentiate 3x, so 3 cancels, dx. We get cos of natural log of 3x by x dx. Okay, similarly dv will be dx, so which means v is equal to x. So now let's do it. Integral of cos of natural log of 3x dx will be equal to x cos natural log of 3x plus, and now we apply this integration by parts. So we have uv, so u or in this case this will be not v, st. So let's say dt, so t, just to avoid, because we have already done it once. Okay, so uv, so now it will be st. S is sine and t is x, so x sine of natural log of 3x minus integral of this will be this one will be t ds. T is x, ds is cos of natural log of 3x dx by x. So x cancels, and here if you notice we have cos of natural log of 3x d, here we have. So if we bring it to this side, this becomes plus, so this becomes 2, and if we cancel 2 from here, this becomes divided by 2. So we end up with x is common to both of them, cos of natural log of 3x plus sine of natural log of 3x by 2 plus c. So that is the integral. And finally, let's look at the 18th one. Integral of sine 3x times e to the power of minus 3x dx. Okay, exponent is the last option. So u would be sine 3x. So du would be cos 3x times 3 dx. dv will be e to the power of minus 3x dx. If we integrate, we get e to the power of minus 3x by minus 3. So let's put this minus on top. Okay. So now assembling the parts, we have uv. So minus e to the power of minus 3x by 3 sine of 3x minus integral of v du. So minus e to the power of minus 3x by 3 times 3 cos 3x dx. 3 and 3 cancels, minus and minus cancel, so becomes plus. Minus e to the power of minus 3x by 3 sine 3x plus integral of e to the power of minus 3x cos 3x dx. Okay, so again something similar is happening. So which means if we do it once more, we will get back the question as one of the terms. Okay, let's do it. Minus e to the power of minus 3x by 3 sine of 3x plus. Now can we see a pattern and figure out? This would become our new u. This will become dv. So since we have already done it many times, let me just directly write it. So first will be uv. So e to the power of minus 3x cos 3x minus uh, integral of minus e to the power of minus 3x by 3 times, and now we will have times minus 3 sine 3x dx. So 3 and 3 cancels. And what do we have? Here we have e to the power of minus 3x sine x dx is equal to minus e to the power of minus 3x by 3 sine 3x plus here we have e to the power of minus 3x cos 3x. By the way, here also there will be a by 3. Okay. Then minus times minus plus integral of e to the power of minus 3x. This minus and minus will, okay, so again we will end up with minus here because there are 3 negatives. So let's take out this minus integral of minus into minus plus, so e to the power of minus 3x times sine 3x dx. So if we take it to the other side, this becomes 2, and if we bring back this 2 to this side, we get by 2. So what we end up with is e to the power of, let's take the cos positive first. So minus 3x minus, no, cos of 3x minus e to the power of minus 3x sine 3x by 6. Okay, now we can simplify it further by saying that e to the power of minus 3x is common, but the exponent is negative. So we take it common out and then bring it down. So e to the power of 3x. So what we end up with is cos 3x minus sine 3x by 6 e to the power of 3x. plus c. So that is the integral. So we saw integration by parts, a very powerful technique. Bye.